I'll first start just to introduce Irene, just to give you a little background of who she is. It's been really fun to get to know her just throughout the process and different meetings leading up to this. But Irene is the CEO and co-founder of mTruth, and she'll be talking about mTruth here. And mTruth chose to focus their foundational technologies in healthcare just because of the impact it can have in improving outcomes while managing costs. mTruth is actually Irene's second startup. And between startups, she was a technology consultant for a number of Fortune 500 companies. Her first startup actually provided software as a service before the SaaS acronym was a thing. So she goes way back, OG on the software as a service. And she also worked for NASA in their Jet Propulsion Laboratory and was responsible for flight and ground software on a mission to Pluto, which is super impressive, and I think is a whole other tech talk that we could do. So if you do have questions about NASA or Pluto, you're still welcome to throw those in there, and I'm sure if we have some time at the end, we'll have Irene answer those as well. So
thank you, Brad. Thank you so much, and I share your sentiment. I really enjoyed getting to know you in the process of this. I'm Irene Warner, CEO of mTruth. So welcome to everyone, and I really encourage people to ask questions. Ask it in the chat, ask it in the Q&A. I think that's the best thing. We have a number of participants, is my understanding. So the Q&A, I think if you have a question, other people will as well. So I'm going to keep this conversation and this discussion at a higher level, so won't dive too deep into the technical details, and just to keep it so that it's more accessible for everyone. But any questions are welcomed, and I really encourage that so that we can make it more interactive. So coming out of NASA, JPL, space obviously will always be near and dear, but today, honestly, our frontiers are digital. So our mission at mTruth is very simple. We want to make using distributed data from any system easy for non-technical users. Today, we're going to talk about blockchain for healthcare and how this technology of blockchain can enable a lot more interesting things beyond crypto, beyond cryptocurrency. And that was the premise for this talk. I won't actually try to sing that war song, just I'll share you guys that thing. But blockchain as a technology has a lot of different applications above and beyond crypto that I personally I think has a lot more potential and is very interesting. So first and foremost, what is blockchain? I think many people think about blockchain as being almost interchangeable with cryptocurrency like Bitcoin, because that's been in the press and in the media, and it has really brought the conversation of blockchain into the mainstream. But blockchain for Bitcoin is just one application. So the way we view blockchain is that blockchain is simply an encryption technology, where a parent block of data is immutably chained to a child block of data, like DNA is passed from parent to child. And so data cannot be edited, it cannot be deleted, it can only be added. And the value of that is not only security for the data, but also this immutability. The fact that you cannot artificially change it, for what the data represents. And so there are a couple of things that are different about it in terms of how data is protected when you're using blockchain at this, what I call the atomic level, at the data level. So traditional databases, for example, there's one centralized copy. And if there is any kind of encryption, generally it is one key, like the whole database, or it has it on one column, because there's a huge performance impact. Otherwise it just simply wasn't really designed for that. Blockchain, on the other hand, is encryption at the data level, where we can protect the data so that, for example, if a database or a file system were to be compromised and the data is protected at the blockchain level, because the connection of the parent data to the child data is a separate, unique key, takes a different key to unlock that type of information. It protects that information so that even if the whole system was compromised, you still have some protection at the individual data level. And so that's one thing that I find extremely interesting. The other thing is that blockchain lends itself well. In fact, many of the early applications were in what we call a peer-to-peer network. And that's what cryptocurrency networks are, peer-to-peer, meaning each node of the data is equivalent to the other node of the data. So they become almost like a clone in multiple locations. And for us, the whole distributed nature of data lends itself well to a peer-to-peer network, where people own and control their own data. And also it lends itself well to robustness in the network because, redundancy is important. If something takes a hit, you don't want everything, to go down. So that's blockchain in a nutshell. It is simply an encryption technology. So let's talk about what cryptocurrency is and, why, there's some conflation of blockchain as a technology with crypto. Blockchain does use, Bitcoin and cryptocurrencies do use blockchain as a technology. It's one of the technologies that's in the application. So cryptocurrency, really started as a replacement for cash. And I think that's an important thing to understand the birthplace of why it comes from and the way that it works that it does. Because it is a replacement for cash, the whole model was for an anonymous and a public transaction with this notion of wallet. So when you think about data, right, the fact that it is anonymous and public is just one spectrum of privileges when you're talking about data. The other extreme end of data and privileges is extremely confidential information that is restricted to just a few, like classified information, right? So regulated industries, like healthcare in particular, where privacy is important, fall somewhere along the spectrum based on the type of data, whether it could be totally public and anonymous or extremely, extremely private. Because it is regulated and privacy is so important, and the liability around it is so important, it tends to fall on the end where you need to have more confidentiality and privilege, and you need to be more on the secure end. This is true not just for healthcare, but for other regulated industries, like fintech, in fact, like bank accounts as an example, or aerospace or energy or automotive, things where data cannot just be free because it can be exploited. In fact, that's technology is agnostic, right? And people need to trust the system in order to actually deploy and use the system. And this is particularly important in places like healthcare. And so that's something to think about. And all crypto is based on what I call a tokenized model and architecture. What does that mean? It means that a token or a coin, represents an asset. And this coin is followed serially through a series of wallets. And that's, basically how cryptocurrency works. Someone wants a transaction. The transaction, in the form of cryptocurrency, is the blockchain, and some metadata, some information about it, small amounts of data. It's broadcast to a network, and there is a way to, in a trustless system, to say, is this a valid transaction? If it's valid, it commits, and that's how data and money is transferred. So this is one model. It's very successful for something that's trying to be a replacement for cash. But just like cash has regulation, cryptocurrency will also need regulation. Because honestly, right now, I tell people jokingly, but it's true. If it was just about the money, I would just launder money in crypto. But that's not what we want to do. We want to do things that we're proud of, things, because technology is agnostic. The purposes that you use to drive it is the difference. And so for us, this is a passion project. For us, it's about the data. It's about doing something meaningful with the data and enabling people to do something with the data. And so why are we advancing blockchain technology? Why do we have to, as mTruth, have to advance blockchain technology for distributed data management? Why aren't the current, what I call the lift and shift models of crypto, like drug traceability solutions in healthcare, a good enough fit in terms of technology model for distributed data management? There's a lot of reasons for that, why it doesn't work right now. But one of the biggest reasons is that big data is not transactional. And that's what the cryptocurrency models are. Big data is defined by the 3V, what we call the 3V, volume. There's a ginormous amount of data. In our case, We don't want a token or a coin to represent the asset. We want a blockchain, the asset itself, which is the data. We want it securing the data. There's variety. It comes from lots of different shapes and sizes. You know, when we talk about, there's a word that healthcare uses, multimodality. What does that mean? It just means that data comes from lots of different places. It could be your healthcare record. It could be the watch that you're wearing. It could be a wearable, you know, that something's been placed on you when you're at the doctor. It can be information from your blood test, you know, et cetera. So data comes from lots of different places in lots of different ways, and the variety is that other piece. The other thing is velocity. It's the speed at which the data is changing. For us, data is a living, breathing thing. It is constantly evolving, constantly changing. And it is not, you know, a static moment in time where it's always the same thing, where a dollar is a dollar is a dollar is a dollar. Data doesn't work that way. You know, this is one of the fundamental reasons that drives some of the innovations that we're working on, because in order to use blockchain for distributed data management, these are the conditions that we need to address. And why is that important? You know, so I usually talk to people and I ask them one basic question. Do you believe that data is strategic and will make you more competitive? If the answer to that is yes, and most successful companies answer yes to that, by the way, you know, then really what that means is that organizations need to be data-driven. It's a different way of looking at data. Right now, a lot of times, the viewpoint is system-driven. What can I do within the confines of one system with this data? And that's not how data in a data-driven culture works. It needs to be looked at holistically, you know, in terms of what data really means. So company culture is certainly key as one of the areas. It starts at the top and permeates to the bottom. The quickest way as a technology consultant, I used to be able to tell whether technology was strategic, is a hint that I used to give people, right? Is that if the CIO reports to the CEO, then chances are good it's strategic. If the CIO reports to the CFO, chances are good that it's a cost center. And it's just, you know, a way to reduce the cost of the necessary evil. So it's really, it starts at the beginning, starts at the top, you know, it's for everybody. And then there's, you know, what we want to do is remove the mechanics of making data difficult to work with. That's our mission at Truth, right? Because governance is what people should be focusing on. You know, data governance is an important part. It's data governance is basically, you know, what are the things that you have in place to make sure you understand what are the systems of record, how the data should be used, what is the right way and the appropriate way to use that data, especially in healthcare, where in my opinion, you know, it should be very, very patient-centric, person-centric, and making the data accessible for people so that they can take action on it, to do something with it. You know, there's always going to be uncertainty, right? It's always the same. And so with the data, what you want to do again is to mitigate and minimize some of that uncertainty. And technology is simply an enabler. It's not a panacea. So, but that having been said, today we're going to talk about the technology. What is the vision for data? You know, at mTruth, this is just our point of view. It's very simple. We want to make data from anywhere easy to use, in days, not months, on demand with one API, where the blockchain community is the one platform of immutable truth. We believe that data, and we embrace, you know, that data is distributed. We know that it's always going to be that it comes from many places, it's in many different shapes and sizes, and we believe that people should own and control their own data. We don't aggregate or monetize other people's data. We're not the Facebook model, we're not the Google model. We believe that people should own and control their own data. As Brad mentioned, you know, truth is foundational. We can be used in a lot of different places to unlock the value of data, but we focused on healthcare because the impact is great. We're changing the way people use data in healthcare, and that impact not just has a good impact on the top and bottom line, but more importantly, it improves outcomes and it makes healthcare more accessible and more inclusive for everyone. And so that's our vision in the driver behind some of the technologies behind what we do. And why is it a problem? You know, why is it so hard? The problem is that while all the systems and devices are online, data continues to be disconnected and combined, it's mainly using data warehouses, which is something I saw over and over again as a technology consultant for the Fortune 500. We'd have these giant teams of IT experts building and maintaining these very expensive data warehouses, but the people that could use the data, they didn't know how to use it. So if a business person or a clinician has a new question, the IT has to rejigger that data because it's structured information and it's one view of the world. We normally would then have to wait till next year's capital budget. It takes a long time, it's expensive. So information technology, we have this thing we call, decades ago we've had this, we call it drinking from the fire hose of data. Now that every system and every device is online, that fire hose just got more ginormous, and now there's a bajillion of them, many of them to drink from. And the impact on it is real. So in clinical trials, for example, 90% of trials are over budget or delayed because it's a complex project that includes data from lots of different places that different people need to see in different ways at different times. That is the nature of data. One system in terms of operational systems just addressed a very specific application of use of that data, which is super important, right? But every time they buy another pinpoint solution, they've created yet another data silo. And so this is what we mean about creating a more data-centric view of the world and having a way to deal with it to make it more easy. So how does mTruth work? We solve the problem of disconnected data. So what our technology does is that it takes data from each of these systems, doesn't matter what it is, and it transforms them into these smaller building blocks, more granular building blocks that are easier and cheaper ways to combine and share, as one immutable version of the truth that can be combined. I like to think of them as like secure Lego blocks that can be used over and over again in new and unplanned ways without any IT assistance. So, and the reason why this is powerful is that now you can enable vertical integration of data. So for example, let's take one of the use cases that we talk about. When somebody's managing a disease like cancer, you need an integration of that data around the cancer, which is an episode of care when somebody has a cancer treatment, for example. So they're getting the prognosis. Sometimes they're going to emergency. Sometimes they need surgery. They have radiation treatments or chemo treatments. There is follow-up, post surgery. There is recovery. There is wellness. All of that information is associated with that cancer. And so you need to be able to integrate that data, vertically. But in healthcare, it takes a village to provide that care. And so that same information needs to be written back horizontally, longitudinally, to all these different providers that have provided that one aspect of care for healthcare. And you want to be able to do that on demand because data should be driven by what you need, what your intention is, as opposed to what the system will allow you, right? You want to be able to be purpose-driven. And the reason why that's important is that otherwise you're just amassing data. And in fact, statistically, over 90% of the data in data warehouses goes unused or not even looked at, unanalyzed. So what you want to do is use data for what you need. So when you can combine different data in different ways, now you can, the endless, limitless ways you can reuse that data, is true. You can use it for distributed clinical trials, the same data. You can use it for the episode of care, like for the cancer treatment. You can provide it for less expensive machine learning training, for example, so that you can now have predictive models for who might be at risk for cancer and be preemptive in that. It allows for collaboration so that different people can take on different aspects of it. And so this is the reason why this is like a data platform, right? So, and we talk about it in a data-centric way. So with a data-centric view of the world rather than a system-centric view of the world, we also want to recognize and leverage that organizations have spent a ton of money already on operational systems and they've invested a lot of resources into it. So we need to support all of that data. So in order to do that, we want to be standard and format agnostic. Anything that they're using, we want to use. When I used to be on standards committees, we would joke, that the good thing about standards is that there's so many to choose from. And that's absolutely true, right? There are so many. And so, people want to use FHIR, which is a standard that the government recently has been recommending, especially for Medicare. If they want to use OMOP, which is something that a large organization of clinicians have defined in the data model, if they want to use OpenEMR, they should use it. Additionally, the healthcare market, like many other markets, the systems are fragmented. There is no clear winner. So even just your electronic medical records alone, there's one organization that we're talking to, one client, they think that you're going to need interfaces to 25 different EMRs. So how do you address that? So some of the things that we do is that we create what we call connectors. Okay, and these connectors are created in days, not months, and you just need to create it once and be able to turn it on and use it whenever you need. And these connectors are human readable. And for those that are technical, they're basically JSON files. They're text-based, easy to read. And what it does is it encapsulates the analysis of how to convert these these systems, that have the source of the data into these, smaller level blockchains that can be used over and over again. And so that is a fundamental difference, because now you can support all of these standards. You write the JSON connector for the FHIR once, and now you can share it with almost anybody in minutes. And that's what you want. You want to be able to use the data for what you need when you need, easily in days, not months. So that you can do something worthwhile with the data. That's ultimately what it is. So I'm going to humble brag a little bit for this one, just to show you that we're not just kind of waving our arms and talking about magic. NASA actually selected us independently, in truth, because we can do what others cannot. And here's how we're actually helping healthcare right now. With the Mayo Clinic and the Society of Critical Care Medicine, there was like an urgent need to quickly and securely share data from many hospitals from around the world about intensive care treatment for COVID. So we had a pilot with Mayo Clinic and SSCM that did that. And the principal investigator at Mayo just loved what we did, and said it's just above and beyond what they expected. And now they have the data, they're reusing that data now for different clinical purposes. And we're now an innovation partner on multiple proposals with them. And Truth was pre-selected by Roche from over 40 plus companies for plug and play Germany's Traceability, where they take interesting and innovative applications and technologies and solutions and try to deploy them in established commercial organizations. We're also a cohort in IBM Startup Accelerator, because IBM recognizes the disruptive potential of what we're trying to do. And I want to share this vision, because if I can even convince one person today that blockchain is good for something other than cryptocurrency and have a huge application, then I consider this a victory and a win. So let's talk specifically about some of these use cases and what we did and how it works, right? So our advanced blockchain and AI technologies do all the heavy lifting in the background. We have an API, it's an application programming interface, that allows people to quickly accelerate, what they want to do with this data, and use this as a data platform so they can focus on the more meaningful things, like doing something interesting with the data. Some of the big differences that we have is that we can blockchain any data of any size, like a surgery video or a 3D model of a printed spinal implant for a true digital twin. This is not just where something's been in a chain of custody, it's about the data. So Bitcoin, for example, has a 10 megabyte size limit. You have one movie, you have one MRI image, and you've blown that 10 megabyte limit. We also hyperlink blockchain. And this is what enables us to be able to dynamically combine data and aggregate data on demand based on what you need and what your purpose is. And that's something that other people just simply cannot do. And I'll talk about why that's useful for this particular assessment application. The other difference is that we're focused on performing at enterprise speed. One of the barriers to adoption for enterprise level blockchain is performance. And you see that a lot. Some of the Bitcoin models, for example, they're starting to change, are simply not sustainable. The amount of electricity that they use to run those, it just doesn't scale, and the approach doesn't scale. So as an example, not to pick on Bitcoin, but they're the most well-known. So Bitcoin, for example, does 4 to 7 transactions per second. We can easily do over 1,000 transactions per second. Others cannot. And that's why we're different. We filed a number of patents We have a bunch of them still in the pipeline. But this screenshot here is for an application for clinical assessment. What does that mean? When somebody's going through a clinical trial of a drug, for example, they want to assess, different aspects of how that's going. So there's, they want to be able to say, in a mobile app that's patient entered, how do you feel today? And capture some of that information. They want to be able to capture and link in blockchain patient consent, because that's super important. The patient controls that consent. They can rescind that consent at any time, and in fact, they can withdraw from the trial at any time. And studies have shown that when people feel empowered and they have control over participation in this clinical trial, then they're more likely to not only participate, but be for the duration of it. The retention of it is much higher. We can integrate now all the different kinds of data, because there's information about, their patient reported how they feel. There's data that clinicians report, with a different application that they're using, all in the same data set. There is information that is from a wearable, because they're measuring some of their vitals, their oxygen level, their blood pressure, their heart rates. And more importantly, now you can use this data again to be able to reuse and use it for other clinical trials. One of the screens shows how you can slice and dice the data in a different way and spin that off and link that to the original source data for a different trial, for a different purpose, for a different clinical study. So this is one use case and one application of it. Another one is, this is the Mayo Clinic use case for this global ICU registry. So what we built for them, was these connectors. This connector, once we built it, because it's following a data dictionary that's already been established by Mayo Clinic and the Society for Critical Care, now they can share that immediately with any hospital that wants to onboard, and press one button and the data gets converted into the blockchain. Additionally, we have what we call the magic decoder ring connector. And the magic decoder ring connector says that in a database, for example, comorbidities, like other stuff that you have, you not only have COVID, but you also have asthma, you have diabetes, you have hypertension, and all of that was represented, in a database ease, where it was 0 for this, 1 for this, 2 for this, 3 for this. Clinicians don't know 0, 1, 2, 3. They don't have to want to remember what that code is. What we did with the other connectors, converted back into English, that says this person has diabetes, this person has asthma, in addition to COVID. We can link now their lung MRI, and so now the same information can now be spun off, and they can spin it off and use it and say, I only want to look at asthma patients, because we can tag data at the patient level as well. And that tagging is automatic, because we're using some natural language tools to help us identify what people have. And now you can tag it so that even though you say high blood pressure, it knows it's hypertension. And you can tag it, and now you can create a set easily for a new study of people that just have asthma. Okay, so this is another use case where you're reusing basically the same data for other purposes. In fact, now they're using it for off-label use of drugs to do a study for that. They're using it for cardiology, because there were a lot of people that had heart issues, long-term COVID. They're using it for radiology, because there were a lot of things that were captured, and all of that can be reused for different purposes. So these are, again, what we're trying to do is make it easy, right? So that what we're doing is we're inverting the process. For those of you who know traditional ways of handling data, there's a process called ETL, extract, transform, load, where you're taking the data from somewhere, you're transforming it, and then you're loading it into a centralized place. And you rinse and repeat that for every different use, every different case. We are completely changing that approach. We load once into the blockchain, and then you transform on demand for what you need. Once you create the connector, you're done. You can just share it over and over again. And why is that important? Because when you take data and you want to use it, let's say to create a KPI dashboard, with charts and trending and so forth, the way that you need to consume that data is different than if you want to use that data to do machine learning, to do predictive analysis on what, something's going to happen. And so you transform the data, what you need, just the asthma patient, transform it to what you need to do, for that purpose. And these can be shareable and reused over and over again. So this is the Mayo Clinic use case in terms of technology. Another use case is for secure proof of vaccination and testing. So a lot of employers, especially in healthcare, are now requiring proof of vaccination and continued testing of their frontline workers because there's a lot of variants and they're going to continually to be exposed. So we can blockchain the proof of vaccination and also link the test results. And because we can do version control, right, the entire history of the test results can be captured, but only the latest test result be shared. And this is shared at an individual level to one person. I only want to share it with Brad. I only want him to know. Or you can share it with the company. You control what that is. Because we believe you should control who gets to look at that data and not your whole health record, just the vaccination proof. We take security also holistically, and this is something that we believe. Security should be designed in at every layer, everything. And so everything we do is secure, even the QR code that you scan. And the QR code is not only encrypted, but it has security embedded in it. Why is that important? If you're going to use it for drug traceability, as an example, you don't want your mailman being able to scan the code and see what you're taking. You want to be able to control and secure who gets to see that data in what context and what they get to see. This is what we mean about the spectrum of control, where anonymous and public is on one end, highly privileged on the other, and there's different uses depending on who you are and what you need to do it for. And sharing can be rescinded at any time because you control your data, and we also blockchain all the logs. We blockchain who touched it, who looked at it, what's been done to it, what is it, and so we do that. What we're talking to some companies is that they want to white label this for employers so that they can use that and use this application. We built it as a lighthouse application. We call it Lighthouse because it just showcases what some of the capabilities are in terms of blockchain for other applications, for healthcare in particular. And so I like to say we drink our own champagne. So we use all our same APIs to build these Lighthouse applications to show what's possible. So another technology tool that I want to talk about is, as Brad mentioned, we're foundational. We can be used in a lot of industries that are highly regulated, like healthcare, finance, automotive, energy, right? So this is a fairly new one. We're working with 2 companies on that want to use this for this purpose. And this is data traceability. So let's talk about it in the fintech context, okay? So more and more industries like finance are starting to use AI and very sophisticated AI models in their business and in operations, and they're being introduced operationally. So like machine learning, which does a predictive or classification analysis to say, as an example, how creditworthy are you, right? And they want to know in regulated industries, how did this model come up with those suggestions? How did it come up with this prediction? How did it come up with this analysis of who is and isn't creditworthy? So what they're trying to do now is traceability all the way back to the data. In one of the cases that we're talking to with the company, we trace it all the way back to actual paper because they digitize the paper. And so we can blockchain the paper because there's a QR code that links the physical to the digital securely. There's the actual physical digital document in blockchain. There's the extracted data, the metadata that they took. In this case, it's invoice data, the vendor information and the invoice. And then the machine learning model, that they pumped it into, they can even blockchain the model themselves. This is a digital twin, right? As well as the result that came out of that model for people to look at this traceability all the way back. Why is that important? Because training for machine learning is only as good as the data. And sometimes the data has bias. So for example, Google, there's some of their imaging for facial recognition that didn't do well with people of color because their training data didn't have enough people of color as part of the training set. And so this can also be the case, right, for something like creditworthiness. What you wanted to do is to make it, truly inclusive and fair and representative of what's happening. And that's one of the reasons, why that's important. And all of it is secured, in the blockchain, including the models themselves, so that it can be predictive. So this gives you an idea of different ways to use blockchain and why we think it's important to shift this model of thinking about data as its own thing. It's all about the data. It doesn't matter where it comes from and what it is, but being able to manage the data and being able to use that data in a good and purposeful way, is really where we think is some of the truly impactful advances will come from blockchain above and beyond crypto.